Okay, we're back with the last few questions of practice test 4A. And so we did the first 21 in the first video. Now we're on number 22. And what we want to do here is solve this equation, natural log of x equals 8. When you have logarithms of a variable in your equation, to solve it, you want to get the logarithm by itself and rewrite it as an exponential. Well, this is ln of x is log base e of x, so this is base e. 8 is the logarithm, that is the exponent or power. And so that's equal to 8, and the answer is done. Because it's an exact answer, you can't do any better than e to the 8th. So there's the answer to that question. The next one's very similar. We have log base 6 of 4x minus 5 equals 3. Notice we have the logarithm by itself, so we can rewrite it as an exponential. The base is 6. The base is the base either place. 3 is the logarithm, the power. So that leaves the 4x minus 5 for the other side. Let's go ahead and do 6 to the third power. 6 times 6 is 36. Multiply another one. 6 times 6 is 36. Carry 3. 3 times 6 is 18, 19, 20, 21. So that's 216. And now we're just solving a little simple linear equation. We want to add 5 to both sides of the equation. That gives 221 is 4x. So x is 221 over 4. And they want it in a exact answer, but it looks like they would rather have a decimal version. So that's a perfectly fine answer. But if we want a decimal version, we could divide this out. And just keep adding those decimals in there. And till we get this to terminate here at this point right here. And so it's 55.25 is x, or 55 1/4 in mixed numbers, 221 over 4, in fractions or in decimals, 55.25. Next question. Okay, this one's a little harder because we need to first try to get a single logarithm by itself first if we can. Now since these are logarithms both base 4, that has possibilities for us because we can put these together. If they have coefficients 1 or -1, which they do, we can combine them together into one single logarithm. The one with the coefficient +1 goes to the numerator, and the one with the coefficient -1 goes to the denominator. And so we can rewrite this as an exponential. 4 is the base, 5 is the power, the logarithm, the exponent, and that leaves x plus 1 over x. Well, there's a couple of different ways we could do this. Let's multiply both sides by x. Maybe we need to figure out what 4 to the 5th is. 4 times 4 is 16. That's 4 square. Another 4. Actually, let's just do another 16. So that's 4 square times 4 square. This will be 4 to the 4th. That's 36. Carry 3. That's 96 plus 160. This is 4 to the 4th here. 256 times another 4 will give us 4 to the 5th. 24, carry 2, 22, carry 2, 8, 10. Excuse me. (1024x) equals x plus 1. Subtract x from both sides. 1023x equals 1. X equals 1 over 1023. Uh-oh, we have a problem. We made a mistake somewhere. Oh, typo. I said 5 here, and I should have said 2. Okay, that would have made all that multiplication quite a bit easier, wouldn't it? because this would be a much smaller number. With that being a 2, this is a 2, so this is 16. Alright, that makes things a lot smaller here. So 16 minus 1 is 15, so this is just 1/15. We could check that, for example, by plugging it in. I think I'm not going to mess with that right now. Let's keep going. Alright, here we have a sequence. Does it have a common ratio? And if so, what is it? Well, the common ratio we divide. So 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 3 is 3. And so our common ratio, which I always call B, is 3. And so that's the common ratio. Okay, 1, 4, 16, 64. Is this geometric sequence? 4 divided by 1 is 4. 16 divided by 4 is 4. 64 divided by 16 is also 4. So that's your base. So this is a geometric or exponential sequence. And we know that it has the form a sub n equals, well, a1 to the base to the x minus 1. That would probably be the easiest way to do it. Or you might write it as a sub 0 b to the x. To do this one, we have to figure out the 0th term, which would be 1/4. And then we have 4 to the x, or I think this one's probably just going to be a better way to do it. 4, because these are the same base anyway, it simplifies. I think this is the form they're looking for. So the first term is 1, and then the base is 4, and then it's just x minus 1. Well, n instead of x. So a sub n is 4 to the n minus 1. And that's the version they were looking for. Okay, what about this sum? 18 plus 6 plus 2. And find the sum. Well, the 3 dots mean you're finding an infinite sum. The only infinite sum we know how to do is a geometric series, and only if the base is between -1 and 1. So let's look at what the base would be. It would be 6 divided by 18 is 1/3. 2 divided by 6 is 1/3. Okay, so it looks like it is geometric with a base of 1/3. Common ratio, a base of 1/3. So what's the formula? In general, if you're adding up the first n terms, you've got the first term times 1 minus the base to the number of terms n over 1 minus the base. But if the base is if and only if, the absolute value of the base is strictly less than 1, then if you add up infinitely many terms, then this part right here is going to get smaller and smaller as n gets closer and closer to infinity. In other words, as n gets bigger, that b to the n gets smaller and smaller, closer and closer to 0. Of course, we know b to the n, that exponential, is going to have just y equals b to the n. It's going to have the x-axis on the right side as an asymptote. The y's are approaching 0. So this is going to approach 0, and so we just get this formula right here. So the first term was 18, and the base was 1/3. So let's see what we can do about simplifying that. So the sum of all infinitely many terms is this. I don't need to multiply the denominator by 3. Let's multiply the numerator by 3 as well. And so when I distribute here, I get 3 minus 1, which is 2. Here I get 18 times 3. So I have 18 times 3 over 2. 18 divided by 3 is 9 times 3. 18 divided by 2 is 9. Take that 9 times 3 to get 27 for the infinite sum. It's pretty remarkable if you think about it. You're adding up an infinite number of things, and yet you get a finite answer at the end. Pretty cool result. Just for practice, suppose we'd only wanted to add up the first, first 10 things. Then you'd have 1/3 to the 10th here. And this would be minus 1/3 here, and you still have your first term, which I believe was 18. And of course you could simplify that. Okay, I believe that finishes up our practice test, and so for the part A, and we'll come back for another video for part B.